Hi guys, Mr. Dr. Logic here, and this is the last module for this course, and I'm so glad it's over. This was actually 2 questions, and it was fairly simple in hindsight compared to all the other modules that we have had to deal with. And it's pretty straightforward and easy, but I'm just so tired and brain dead that I couldn't even do it properly, despite what you're gonna see here. Okay, so the first question that I got dealt with anyway was question 1 out of 2, basically asking about racial composition of uni students. As you can see here, there are 6 choices, maybe. And then, yeah, the question is asking, is there a racial composition of the university? Hang on. Yeah, is there a racial composition of the university representative in general? So they're trying to see who makes up the majority or who makes up the minority. Okay, so we're given that set of data right here. So we're given this, and we're given this immediately. Okay, so make a question straightforward, or to answer the question straight up. I thought of going about it like this, but it's just terrible, and it just feels weird. So I'm just gonna go straight to the Excel. As you can see here, I summarized it as this because that's basically what it's asking. I said here the answer is categorical because in the question here you have to identify yourself as one or the other. And so, yeah, you get the idea pretty straightforward and pretty quickly. So if I had to explain binary, binary is either 1 or -1. So you're in group A or in group B. If there's like an in-between or something, then it's C. Then you would automatically make it continuous. But since you're categorical, you're putting yourself quite literally in one category or another. However, for continuous, you do the same thing, but there's a little bit more variability where you go like 0 to 100 or like -100 to 100 and so forth. Okay, so binary and categorical are pretty straightforward and simple. All you gotta do is put a 1 or a -1, or you just gotta put a 1 in a specific category, while as continuous is just more variable. Okay, here you might think, or you might assume, according to the question, that there are 6, when in fact there are actually 7, because if you count 1, 2, 3, 4, 5, 6, and you put 6, that's the wrong answer. All right, guess why? Because if you read on here, the percentage of citizens who do not specify their racial category, it tricked me. It tricked me. The data lied to me. You see this? You see this? There was no number 7. There is no number 7. They don't tell you this. They don't tell you this. The question straight up hid it from me. So yeah, there is 7 categories. Okay, so for the next question, it's is a person allowed to pick more than one category? The straight answer is no. You're allowed to be one or the other. You did not specify your race. You're either Asian, mixed, Hispanic. You get the idea. Pretty straightforward, pretty quickly. Okay, so now for this one's a little tricky, okay? So is the choice of one person independent from the choice of another? Oh, yes. Okay, so the correct answer to this, as I put, is the choice of one person independent? So the correct answer here is yes, because just because you put yourself in one category doesn't mean it should influence another person on another category, especially given this question. It's not like you making a choice will affect another person to change who they are immediately because you made that choice. There is no such peer pressure here. And then so if we continue down, can the different be considered single factor, a way of signaling organizing them? Correct answer here is yes, because it is in fact single factor. There's no other thing that's being accounted for besides their race. And then so for the degrees of freedom in this experiment, obviously it's simple. 7 minus 1, which is 6. And then enter the predicted frequencies. Okay, so this is where it should be wild, all right? So as you can see here that these are the numbers, obtained values that we were given. So from here, from earlier from the question, and then this is, yeah. Actually, you know what? I highlighted the wrong one. Ignore that. Okay, so this is the percentage, and this is the obtained values. I don't know why they put this in. Like, this is just to fuck with me. So they put this in this order. And so what you're supposed to do here is take the sum, which is, as I stated here, 932, and you're supposed to multiply them by each one. So it's going to be put into a box, and you're going to have to fill them all out. And it says here in whole numbers, so as you can see, come on. God damn it. You know, I'll just scroll out. So for each population, you multiply it by 932. So if I just pull out the calculator, pull it down, and if we compare the thing, so we'll just put 576, nope, 932 times 59.1899. We immediately get that, but of course, divided by 100, we get 5510. You can see that there's some variability. That's why I ask you to put it in whole numbers, because they give you 4 of the percentage when in reality they're not giving you the whole thing. If you wanted to be more specific, you could try doing this, and then from there multiply by 932. Never mind. Okay, so ignore me, okay? Ignore that last bit. So yeah, just multiply this with this, you got your answer. And if you multiply 4.3428 times 932 divided by 100, it's at the 41 right there. Did I miss a number? I think we just, yeah, we flat out skipped a number. I don't know why. I think I might have cut that out. Okay, so yeah, we'll just use the percentage. So we're given the six percentages over here, and we multiplied and we got all of them. So here, oh my god. So here earlier we were given all the percentages for it. I think it was 1.07, but we'll ignore that for now. So let's continue out. And so for this one, it's not sample means, it's not sum of ranks, because that's not what we're looking for here. We're looking for this test statistic for this design. By process of elimination, we're not trying to look for any average here, and we're not trying to look for the sum of any ranks, because we did not calculate any ranks. So through process of elimination, it's percentage chi-square. And then, so what did you get for the null hypothesis? So basically, in this case, obtained... Actually, what will make more sense if I do this? Null equal to 6, because it's also equal to the df. We calculated the df earlier, which was 7 minus 1, which gives you that number. So that's what the null is equal to. And then for the research hypothesis, it's A, because we're not trying to disprove it. So that's immediately out of the question, because if we scroll up to the question earlier, is the radical composition of this university representative city in general? So immediately it's not C. B, I honestly guessed, and it was not B either, so the correct answer here is A, and it supports it further. And then you might be wondering, compute and enter the... Okay, now this was just terrible. This was just too hard to explain. There are not words to justify or explain how tedious and annoying this was. Like, on the Excel, I made it look simple, but in reality, this was just straight up pain. So all you're doing here is you're going to take the 576 minus the 552 and then squaring it, and then okay, so basically what you're doing here is you're taking the obtained minus the expected, squared all, and then divided by the e, and that's just for one of them. So that's just for one of them. And so if we were to do this with the calculator, which I got rid of, god damn it. Okay, so 576 minus 552 squared divided by 552 . Okay, so you can already see here how this is going to be a bit of a challenge. So then you get all these values and you have to do them independently. So 89, and if you take this value, oh boy, we'll go back here, 119 minus 89 squared divided by 89. Get this answer, and then from there you continue the whole process. You add them all up, and that's your final x squared value. That's your obtained. So if I were to fuck with any of these, such as making this 20, it immediately changes, because it affects this, and it also affects this. If I were to put this back to 18, all these values switch back to what they were. I don't know why everything else is switching. Oh, that's because it's affecting the total as a whole, and that's why it's affecting the rest of it. Yeah, my bad. But you do understand how this is happening. So, it is what it is. This is how you get it. And then cut to the video showing how to do the graph. Hi, this is Mr. Dr. Logic in post-recording after making all the edits, just realizing he might have missed a few things. So let's just continue from where we left off. We figured out how to get this value pretty much from adding everything else up. Okay, and then so from here we continue to determine if it's F or T or chi distribution. Obviously, if any of you saw the graph and you're paying attention to what's down here, you're straight up getting the answer. It's not F distribution, it's not T distribution. There's no way I can explain it. For one thing, I can definitely say it's not two-tail. It's definitely not two-tail, so I would strike T immediately off. As for F distribution, I simply don't know how to define it, but all I know is that the chi is correct because we've been seeking the x squared, and somehow those two synonymously go together. I mean, we've seen hints where it's like x squared, so I guess that's it. And it also has something where it's like categories, and any category expected value is greater than 5. So minimum, yeah. So there we go. What's a DF? Oh, okay. I see how it is. All right, okay. No need to be like that. I need to be so juicy. And then from there, you simply reject it because, as it's nicely put, 24.74 is simply out of the range. So we just straight up reject it. Now, as for question 2, holy moly, this was a nightmare. Oh my god, this was a holy moly nightmare. Okay, so for the student opinion, okay, midterm, okay, just ignore this part, okay? So what they were asking is, there were a number of students I got F, D, C, A, B. I can relate because I'm very here. And I think the exams are fair despite failing it altogether, but we'll ignore that bit for now. Now, again, like stated before, you're putting yourself in a specific category, and the question asks, what did you expect your grade was, and how fair do you think the test was? And so this is quite literally what it was asking. So obviously, immediately it's categorical. How many categories? Careful. This question is very tricky, okay? This is one category. This is another category. And this is another category. So if they're all independent, the correct answer here is 20. Sorry guys, I've been talking a lot, so I sound very dry and have a cold. Okay, can a person be classified as more than one category? Obviously, the simple answer here is no. You belong in one or the other. Okay, so is the person of one choice independent from the choices of others? This is an easy yes because there's no way that your answers here, that your grading is going to affect any of the things like this. We have to go out of our way to make sure that this doesn't happen. Otherwise, this immediately invalidates any results we give. Okay, and then so how many degrees of freedoms are there? Well, this is simple. So since there are 5 on this side, and then there's 4 on the other side, which is -1, and multiply it with its -1. So we get 4 times 3 is 12, equal to our DF. And so if we scroll down, where's the DF? There's our DF. And so I just included this bit because I needed room, and I also fucked up unintentionally. So what we have to do here is just a straight up pain in the ass. It is just straight up a pain in the ass. As you can see here that these numbers are not the same as these numbers. Yet again, we're asked for the whole numbers. Oh wow, it doesn't even tell me that. Yeah, round your answer to whole numbers. So if you were to take that into consideration, I did it right. But the only reason it's not the same is because, yeah, it wants it in whole numbers. Obviously, I made the Excel for it, but in the walkthrough, you're going to see how much of a pain this was. So what you're going to do is you're going to, oh my god, chill. You're going to have to take the sum of each category. So if I wanted to figure out 12, I'm going to take the sum of its row, which is 94, and the sum of its column, wait, no, sum of its column is 94, sum of its row is 69, and then divide it by 674, which is just simply the n total, or just the n, 74, and then we get like an average number of 10, and this continues. So we do 92 over 69 divided by 64, we get somewhere around 9, and I'll just prove this to you. So 69 times 94 divided by 9, and there you go, whole number 10. And then so we'll do another number, 43, right here. My mouse gravitated to it. 30 times 773, 674, 33. And then we'll do another number. Yeah, this huge one. Okay, so 204 times 383 divided by 674. And there you go, 116. So this is pretty much how you do it. It doesn't seem that bad, but doing them all out repetitively, it gets annoying. And so you got to fill up the whole table. And then for the x obtained, which is the next thing it asks, it is the obtained, which is 12, minus e, which is the 10, because we're assuming that there's no interaction between the two. So obtained minus expected squared divided by expected, and we get these values. But it doesn't matter because we're summing all of these up, and we get a collective value of, I don't remember, I think it was not 14. It was somewhere around 14, could have been, not too sure. But yeah. So yeah, we get pretty similar numbers. So we continue down, as we stated earlier. We're not looking for sample mean, we're not looking for sum of ranks. This by default is the answer. And then so what is the expected? Obviously, like previously mentioned, df, which is the 12. And then, as previously stated, these two don't count. We're not looking for this. Trial and error for me. And so the answer is A. Research hypothesis. Oh my god, it's 40. Never mind, I lied. Holy shit, it's 40. So let's continue over. Oh, there's a 10. And there's a lot of other stuff going on. So the sum of all of this turns out to be 40. I'm not going to add all of this up, just believe me when I say that this is 40. So adding all of this up gives you 40. Obviously, you're not told to do this part. You just have to do this part and record the number somewhere, and then just simply add this all up. And then so we can continue down. We already know we're not looking for the F distribution, we're not looking for the T distribution. Automatically chi, because as the module puts it, different categories are mutually exclusive. They fall into one or only categories, and they choose it, and they're independent. It's greater, whatever, just whatever. Just know that this is chi because of minimum expected value is greater than 5, and it's different categories. As for the x value, we have determined because of the 0.75. And then finally, we get this value. Lower bound, upper bound, you can see it right here. Our value was 40 something, 5. Obviously it falls out, so we reject it immediately. And that's it for module 15. And as for the last bit of this thing, it's the end of the modules. And for everyone else, good luck on the exam. And I hope everyone did on the midterm. Did well on the midterm, alright? I'll see you guys in the next video.